Is there more to marijuana than meets the hype? In this episode of To Science Today, we explore the use of marijuana in treating cancer. Do the benefits outweigh the risks? Are they better than conventional medicines? And if they are, how should they be regulated? Within the marijuana plant, also known as cannabis sativa, exists over 100 different cannabinoids, although the majority produces little to no psychoactivity due to the inability to activate certain receptors, called cannabinoid receptors. The most commonly known component of marijuana is delta-9 THC, responsible for its psychoactive effects. Other than its recreational use, THC has also shown promising results in anti-tumor effects. Cannabidiol is another major component of cannabis sativa and also has implications in anti-tumor activity.
THC and cannabidiol, or CBD, act in similar ways to chemicals that we have in our bodies. They do this by interacting with CB1 and CB2 receptors. CB1 receptors are in higher numbers in our central nervous system and produce the psychoactive side effects, whereas CB2 receptors are more present in our immune system and are on B lymphocytes and natural T killer cells. Both of these are present on cancer cells but are not present on the healthy cells from which they originated. It is this that we can use to target anti-cancer treatments. Previously, THC has been used for its antiemetic and pain-relieving qualities. New studies have shown that CBD and THC in combination with chemotherapy enhances the effects of the radiation. Also, the CBD and THC combination reduce the undesired effects that you get from THC and enhances the anti-tumor effects that you get from CBD. Delta-9 THC mimics endogenous chemicals and has anti-tumor actions that target cells, killing them via pathways that start with binding of CB1 receptors. It also stops the spread of cancer by inhibiting matrix metalloproteinases. In a cancerous neuron or glioma, stimulation of the CB1 receptor inhibits adenylate cyclase and voltage-gated calcium channels. It stimulates potassium channels and mitogen-activated protein kinase cascades. The combination of all these mechanisms in turn causes cell death. Inhibition of cancer spread or metastases involves matrix metalloproteinases, or MMPs, which play an important role in the invasion of tumour cells. The MMP levels are raised in many cancer types and are associated with the disease progression. Delta THC has been shown to be able to inhibit cell invasion by downregulating MMPs, therefore stopping the spread of cancer. The actions of cannabidiol are similar to THC but work through different pathways. Unlike THC, it kills the cells by producing reactive oxygen species, creating cell stress. It has a few mechanisms to stop the spread of cancer and also stops angiogenesis, or the formation of new blood vessels to the cancer cells. Reactive oxygen species production is one process in this cannabidiol-dependent inhibition of cancer cell aggressiveness. Cannabidiol reduces glutathione and related enzymes. These are important antioxidants that prevent damage to cellular components by reactive oxygen species. Cannabidiol also causes cell stress by disturbing the mitochondrial membrane. The cumulative cellular stresses lead to activation of multiple cascades, ultimately killing the cells. Cannabidiol has a few mechanisms to also stop the spread of cancer. For example, recruitment of tumour macrophages that target the cancer cells, upregulation of associated MMPs, and even turning off a gene called ID1 that increases the spread of cancers. The main action of cannabidiol is stopping the generation of a new vascular supply that the tumour uses for gas exchange, cell nutrition, and waste disposal. Cannabidiol reduces expression of vascular endothelial growth factor and its receptors, as well as other pro-growth cytokines, ultimately reducing the blood supply to the tumour.
A national clinical trial was announced in October 2014, but legalization could be years away.
The trouble with medical marijuana is that the rules are likely to change state by state. So it might be approved in Victoria or New South Wales, which then needs people moving. So in America, where they've legalised cannabis in various places, they've found a huge influx of people moving to those places because they want to take cannabis. So it's only legal as a medical use, but people find all sorts of reasons to get a prescription for marijuana. The minute it becomes a pill and more like traditional medicine, then people are going to probably accept it more. but if it's in the form of a leaf or something that somebody needs to smoke or ingest, then probably they can associate that with drug use and be more hesitant to take it. So I suspect it's a lot to do with that personal preference and just personal opinion around drugs.
The New South Wales government invested $9 million over the next 5 years on clinical trials that would explore the use of cannabinoid drugs. Pockets of high-quality research exist across Australia, including research by the National Drug and Research Institute. However, research lags behind in drug development and use. Although prior studies have found clinical evidence of the use of cannabinoids for cancer treatment, evidence is minimal in determining its associated risks.